Hello, and today we're going to be talking about the ancient Greek mystery, the Pythagorean Theorem. It has to do with right triangles, and this is the formula, basically. And okay, I'll explain what this means. So if you take the square of length A and add the length B, take the sum of those, and it equals C squared. Okay. So this is A. This side of the right triangle, which is known as a leg. The legs are the two lengths that create the right angle. B would be this length, right here. So, and then you got here, which is the hypotenuse, which is the longest side in a right triangle. We call that C. Okay, so basically this is how you can find the length of the hypotenuse given the two lengths, given the two legs. This is how it works. So you say length A is 3 and length B is 4. How do we find C? Okay, so basically we plug it into the equation. We do 3 squared plus 4 squared equals C squared. Okay, so this is what we do. We simplify the exponents. We got 3 squared is 9. 4 squared is 16. And equals C squared. Now 9 plus 16 is 25. It's equal to C squared. Now, since 25 equals C squared, we need to find the square root of C squared. And by doing that, I need to find the square root of both sides. So the square root of both sides, square root of C squared is C. Square root of 25 is 5. 5 is equal to C. So C is equal to 5. That's how you would use Pythagorean Theorem in a geometric sense, or an algebraic way. There are a bunch of different proofs and geometric proofs, and this is the algebraic proof that is demonstrated. So now we gotta move on to our next topic, which is trying to see if you're given the 3 lengths of the sides of the right triangle, is it a right triangle? That's called the converse. We're back, and today we're going to be talking about the converse of the Pythagorean Theorem. Alright, so basically this is how it works. Say we're given the lengths 3, 5, and 7. Well, obviously we know that 7 is the hypotenuse because if you remember correctly, the hypotenuse is the longest side in a right triangle. This side right here. So say we're given the lengths 3, 5, and 7. Could these be the lengths of a right triangle? That's basically what the converse is. Given the lengths, you can find whether or not these can be the lengths of a right triangle. So this is what we would do. If 3 squared, plug it into the equation, 3 squared plus 5 squared equals 7 squared. So you would solve it. You do 9. 3 squared is 9. 5 squared is 25. Equal to 49. 9 plus 25. It's the 34. Is 34 equal to 49? No, it is not equal to 49. So we know that this is not the lengths of a right triangle. Now, however, if we were given, say, 5, 5, 7.1-ish, you do 5 squared plus 5 squared equals 7.1 squared. This is equal to 25 plus 25 is equal to 7.1 squared is roughly 50, so we'll do that. So 50 is equal to 50, and that is approximately, 7.1 squared is approximately 50. It's not spot on, but it's if you round it, it's around 7.1. But still, you get the idea. You get the idea. So we went over the Pythagorean theorem, which is up here, which is at the top here. The Pythagorean theorem is if you give them the lengths A and B, you can find the length C, which is the hypotenuse. We went over that. And also we went over the converse, where if you're given the lengths A, B, and C, could they be the lengths of a right triangle? So basically you plug these into the equation. And by the way, the lengths are interchangeable. You can plug in 5 for A or 3 for A. It doesn't matter. Commutative property of addition. But you always gotta use the longest, the biggest of the numbers for C, because the hypotenuse is the longest side in the right triangle. So I hope you found this video educational, and I will see you later.